Our next speaker is Liyi, and he's going to talk about DeFi hack detection and prevention.
Thank you. So we are a bit late already. I will go really fast. So I'm a co-founder from D23E, and we are working on different aspects of the security lifecycle. So typically, there are three very important cycles for any attacks. So there's the before launch. We do kind of auditing, and we also use automated tools to find vulnerabilities, formal verification, fuzzing, etc. We also have after launch security. So we have like vulnerability search, intrusion detection, prevention, etc. And also after incident, right? We have circuit breaker, etc. So the core members of D23E has worked in the entire cycle of DeFi security, and we have quite a lot of publications here. So I would like to share 3 publications we have done this year, collaborated with other world-leading researchers. The first one is the blockchain imitation game. In essence, we detect attack transactions in the mempool, and we copy the adversarial contract to create our imitation contracts. And we also generate an imitation transaction. And then we front-run the attacker and steal the profit they will earn. And then we will return the profit to the DeFi projects. That's the first paper. So for technical details, you can check out the link on the top. The second paper is blockchain large language model. So in essence, we build a large language model trained on previous transactions for DeFi protocols to learn what's the normal behavior for transactions. Then once there's an abnormal transaction enters the system, we will try to rank the transactions, and if it passes a certain alarm threshold, we will issue an alarm. And this will trigger potential defenses, such as emergency pause. That's the second paper, and the result is 49 out of the 124 attacks among the top 3 most abnormal transactions for past attacks. The third paper I want to share is this: do you still need a manual smart contract audit? The answer is yes, for sure. But what we actually did in the paper is we have this data set with 52 DeFi attacks with the source code and the actual vulnerability. And we also have a vulnerability list from one of our previous papers listing all the vulnerabilities we have in DeFi. And then we do some prompt engineering, ask large language models if there's an attack in the smart contract or not. The answer is yes or no with some detailed specification of the vulnerability. And then we compare the answer given by large language models with the actual vulnerability. And we found out that both GPT-4 and Cloud can correctly identify 40% of the vulnerabilities. But the downside is having a very high false positive rate. So that's it. Thank you.